So in this video, I'm going to deal about the concept of moles. Yes, you already know what are the relative atomic mass and how to find out the relative molecular mass. So relative atomic mass, which is represented by AR, which we can see from the periodic table for every element. It's a relative atomic mass is the mass of a particular element, taking into consideration the isotopes and also the abundances. So for every element, there is atomic mass, which we actually get it from the periodic table. So then relative molecular mass is simply add the relative atomic masses of all the elements which are present in that formula, then we are going to get the relative molecular mass of that particular molecule or the compound. For example, if I want to find out relative molecular mass of water. So in this, you can see that there are two hydrogens. So there are two hydrogens and there is one oxygen. So relative atomic mass of hydrogen from your periodic table. So relative atomic mass is represented by AR. So H is 1. So this is a rounded off 1 actually. And oxygen is 16. So there are two hydrogens. So 2 into relative atomic of hydrogen and 1 into relative atomic mass of oxygen, which is 16. So 2 plus 16, which is nothing but 18. So this is the relative molecular mass of water. So simply, if you add the relative atomic masses of all the atoms which are present in it, of different elements, then we are going to get the relative molecular mass, as simple as that. For example, if I want to find out relative molecular mass of carbon dioxide. So what is it? There is one carbon in this and two oxygens. Yeah. So a relative atomic mass of carbon is 12, again from your periodic table. So 1 into 12 plus 2 into 16 because there are two oxygens. So 12 plus 32, which is nothing but 44. So this is how you find out the relative molecular mass of any compound. So provided you know the relative atomic masses, which we can actually get it from the periodic table, we can find out the relative molecular mass just by adding relative atomic masses of all the elements. For example, I want to find out relative molecular mass of calcium carbonate. And you can see there is one calcium, one carbon, so relative atomic mass of carbon into 1. And there are 3 oxygens. So relative atomic mass of calcium is 40 from your periodic table. Carbon is 12, oxygen is 60. So 1 into 40 plus 1 into 12 plus 3 into 16, which is 48. So if you add all this, it comes up to 100, which is relative molecular mass of calcium carbonate is 100. Yes, this is how you find out for any element, any compound, provided you know the relative atomic masses, we can find out the relative molecular mass. Yes. So next thing which we're going to read here is how to find out the percentage by mass of a particular element in the compound. So percentage composition of a particular compound. So percentage composition. So it's very simple here. For example, I want to find out what is the percentage composition of water. Okay, so what is the percentage composition of water here? Yes, so what do you do is, yes, I want to find out percentage composition of water. That means of hydrogen, how much it is contributing to the total mass of water. So percentage by mass of hydrogen in water and oxygen in water. So what do you do is, yes, mass of hydrogen in that, which is nothing but 2 hydrogens, by molecular mass of it into 100. Yes, so relative atomic mass of hydrogen is 1. Molecular mass just now we calculated it's to be 18 into 100. So 2 by 18 into 100, which comes out to be 2 2 by 18 into 100, which comes out to be 11.11%. Similarly, what is the percentage by mass of oxygen in water? Is, yes, how many oxygens? There is only one oxygen in the formula, if you see, of water, which is H2O. So relative atomic mass of oxygen, that means how much it is contributing to that into 100. So 1 into 16, because there is only one oxygen, divided by 18 into 100. So which is coming to be 88.88%. So this is how you calculate percentage by mass of a particular element in the compound. Yes, based on the question asked, yes, you can find out of the whole compound, that means each and every element in this, or a particular element which is asked. So for example, if I want to find out question 2. So what percentage of the mass of the compound of the mass of the compound of the mass of the compound is nitrogen? What percentage of the mass of the compound is nitrogen in ammonium nitrate? So the formula of ammonium nitrate is NH4NO3. So this percentage by mass of nitrogen, they're asking you in ammonium nitrate. First of all, you should find out MR of ammonium nitrate. So MR of ammonium nitrate is, there are two nitrogens. So relative atomic mass of nitrogen into 2. There are 4 hydrogens, relative atomic mass of hydrogen into 4. Plus there are 3 oxygens, relative atomic mass of oxygen into 3. So nitrogen is 14. So 14 into 2 plus 4 into 1 plus 3 into 16. So 28 plus 4 plus 48. So which is nothing but 80. So yes, once you have found out this, yes, mass of nitrogen in that, how many? There are only 2 nitrogens. Divided by the MR of it, which is 80 into 100. So 2 into 14, which is 28, divided by 80 into 100. So which is equal to 35%. See, this is how you find out percentage by mass of a particular element. And if you know the formula, it's just the substitution there in that formula. And then, yes, finding out the relative molecular mass of that compound and then substituting there gives you the percentage by mass of a particular element in a compound. Yeah. Coming to the actual concept of moles. Yes, what is a mole? Mole is just the counting. Is the mole? Mole is just the counting unit. Yes, it is the counting unit. So you know that the atoms are very, very small. It is not visible to our naked eye. You need to observe it in the microscope if you want to observe it. So if you take a small mass of the substance, very, very small, it has many, many atoms, billions of atoms of that kind which is present in it. So it's very difficult to deal with such large numbers of the atoms which are present in small masses. So what they thought is, okay, to deal with such large numbers of atoms, let us introduce the concept of mole, where mole is the count. It is referring to the amount of substance. What is it? It's just the amount of the substance which is present. Amount of the substance. And the units of it is just mole, M-O-L, M-O-L. It is represented by M-O-L. And if you see, 1 mole of any substance contains Avogadro number of particles. If you see any substance, it contains 1 mole of that particular substance contains Avogadro number of particles. That particles can be atoms, that particles can be molecules or formula units. Yes. So what is it? It's just the contains 1 mole of any substance contains 6.02 into 10 power 23, and this number is the constant which is called as Avogadro constant. This many number of atoms, molecules or formula units. Depending on the substance we are talking about, yes, it can be atoms, molecules or ions or formula units. So 1 mole of any substance contains so many particles. Just that is why we are calling it as what? Particles. And what is its mass? Its mass is equal to its relative molecular mass expressed in grams. For example, the mass of 1 mole of water is equal to, yes, what is its relative molecular mass of water? Just now we have seen 18 expressed in grams G. That's it. So mass of 1 mole of water is 18 grams, or mass of 1 mole of water is nothing but molar mass. So molar mass of water is nothing but its relative molecular mass, which is 18 expressed in grams. So molar mass of water is 18 grams, or mass of 1 mole of water is 18 grams. Or if I take molar mass of carbon dioxide, just now we have calculated relative molecular mass of carbon dioxide. So relative molecular mass of carbon dioxide is 44, expressed in grams is nothing but mass of 1 mole of carbon dioxide, or molar mass of carbon dioxide is 44 grams. Yes. So this is how you calculate relative atomic mass using relative atomic mass as relative molecular mass. And just expressing it in grams gives you the molar mass of that particular substance. As simple as that. So let's understand a little more about the moles. For example, if I'm talking about the substance carbon, so I'm talking about the substance carbon. So the symbol of carbon is C. And what is its relative formula mass or atomic mass or molecular mass? Yes, because it's an atom, we called it as atomic mass. This is nothing but 12 from your periodic table. And mass of 1 mole of that substance, which is nothing but molar mass. Just now we said molar mass is nothing but its relative molecular mass expressed in grams of it is atoms. Relative atomic mass expressed in grams, which is 12 grams. And this mass contains, that means 1 mole of any substance contains, just now we said, Avogadro number of particles. So this mass, which means 1 mole, contains how many particles? Avogadro number of particles, which is 6.02 into 10 to the power of 23 particles. And what are those particles in this case? They are carbon atoms. So much of information here. 12 grams of carbon contains 6.02 into 10 power 23 carbon atoms. Or 1 mole of carbon has a mass of 12 grams, which is nothing but molar mass. So 1 mole of it is 12 grams, and 1 mole of this carbon contains 6.02 into 10 power 23 carbon atoms. And you can do this for any substance, for example, iron. So the symbol of iron is Fe. And relative atomic mass of iron from your periodic table is 56. And molar mass, just 56 grams, its relative atomic mass expressed in grams. And how many particles it has? Same number of particles, but now here, this is not carbon atoms, but iron atoms, because we are talking about iron. Just now we said, yes, so many particles it has depending on the substance we are talking about, because we are talking about iron, we are considering iron here. So it will be having 1 mole of that particular iron substance. That means 56 grams of iron has Avogadro number of iron atoms. Okay, let's see one more example where we are dealing with hydrogen. For example, hydrogen. So I'm talking about hydrogen molecule now. So the formula of hydrogen molecule is H2. And because it is a molecule, it will be molecular mass. So relative molecular mass of hydrogen is nothing but, because there are 2 atoms of hydrogen and relative atomic mass of each hydrogen is 1. So this should be 2. So molar mass is 2 grams. Yes, 1 mole of that particular substance is nothing but its molecular mass expressed in grams, and this has 6.02 into 10 power 23. And what are these? These are not atoms now. These are molecules. What molecules? Hydrogen molecules. See? Because we are talking about hydrogen molecules in this case, yes, it has so many number of hydrogen molecules. Simple as that. For example, oxygen. I am again considering molecule O2. And the relative molecular mass of this is what? There are 2 oxygens. So 2 into 16, which is 32. Because relative atomic mass of oxygen is 60. So it is 32 grams. So molar mass of it is how much? 32 grams. And it has 6.02 into 10 power 23 oxygen molecules. Yes, we can talk about any substance. For example, okay, water. Now, still now we consider the molecules of the elements. Now, let us consider the molecule of a compound, which is water, where formula is H2O. And you know that its relative molecular mass just now calculated twice 18. So, 18 grams. Molar mass of it is 18 grams. That means 1 mole of water weighs 18 grams. Or the mass of 1 mole of water, its molar mass is 18 grams, and 1 mole of any substance contains Avogadro number of particles, and those particles in this case are water molecules. So 18 grams of water is 1 mole, and 18 grams of water has 6.02 into 10 power 23 water molecules. Yes, it's the same number, but every case the substance is different. For example, it is magnesium oxide. So magnesium oxide, relative atomic mass of magnesium is 24 and oxygen is 16. So it is 40. So now this is called as formula mass, because MgO is not a simple covalent molecule. It's not a molecule. It's a ionic compound where it exists in the form of a lattice structure oppositely charged ions. Because it is an ionic compound, we don't say that as what molecules. So 40 grams of magnesium oxide has, because that is 1 mole, or 1 mole of magnesium oxide has 6.02 into 10 power 23 magnesium oxide, and these are not molecules, they are formula units. Calculation is same, but only thing is the terms which we are using, it's different. As long as it is a simple covalent molecule, they're calling it as molecules. And when they are ionic substances, we are calling them as formula units. So they can be atoms, they can be molecules, ions, formula units, or electrons. Yes, 1 mole of the substance contains Avogadro number of particles, and that particles can be atoms, molecules, or ions. And how do you find out the molar mass? Mass of 1 mole of the substance is nothing but its molar mass. And yes, it's just relative atomic mass expressed in grams, or if it is molecules, relative molecular mass expressed in grams. That's it. Let's see calculations involving the moles. So for a given mass of a substance, you want to find out how many number of moles of that particular substance is there. Okay, whatever it is, atoms, molecules, or formula units. Certain mass of it is given, and you want to find out how many number of moles does that mass of substance has. You can simply use the formula number of moles is equal to mass, given mass, that means the mass of that particular substance, divided by its molar mass. And this is a formula which is very, very important and which we are going to use in your numericals. So number of moles is represented by N, mass small m, and molar mass by uppercase. So this is a formula. N is equal to m by m. Number of moles is equal to mass of that particular substance by molar mass of that particular substance. And yes, so it is represented like this, if you can see. So mass is nothing but, I can rearrange this formula. Mass is nothing but number of moles into molar mass. Yes, depending upon what is being asked, I can rearrange this formula and find out whatever the variable I want. Yes, that's it. For example, let's see this question based on this formula. How many grams are there in 60 grams of sodium hydroxide, where the formula of sodium hydroxide is NaOH? How many grams are there in 60 grams of sodium hydroxide? So they are asking for the mass. How many grams? Sorry, how many moles? That is not grams. How many moles are there in 60 grams of sodium hydroxide? So they give you the mass, which is 60 grams, and asking for the number of moles. And yes, you know the molar mass just from the formula of sodium hydroxide. So molar mass of sodium hydroxide is, so relative atomic mass of sodium is 23, oxygen is 16, hydrogen is 1, which is nothing but 40. So number of moles is equal to mass by molar mass of that particular substance, which we are using this formula now. So mass is 60, molar mass is 40, which is equal to 1.5 moles. See, as simple as that. Yes, 40 grams of it is 1 mole, 60 grams should be 1.5. Yes, logically also you can think like that. Otherwise, you can just deal with this formula if the numbers are big. Question 2. What is a mass of 0.5 moles of copper to sulfate crystals? Yes. In this case, they are asking you the mass. They gave you the number of moles, which is 0.5 moles. And molar mass of copper to sulfate crystals. What is the formula of copper to sulfate crystals? So they're talking about hydrated copper 2 sulfate, whose formula is CuSO4 5 water molecules dot 5, which means it is hydrated. So in this case, while finding out the molar mass, you should also include 5 water molecules. So relative atomic mass of copper is 64, sulfur is 32, oxygen is 16, hydrogen is 1. So copper is 64, sulfur is 32, plus 16 into 4 is 64, plus 5 into 18, because there are 5 water molecules and relative molecular mass of water is 80. So if you do all this, it should be coming up to 250 grams. So once you find out relative molecular mass, now apply your formula. Number of moles is equal to mass by molar mass. And just rearrange this formula because in this case, they are asking mass. And you know the number of moles. So M is equal to N into M, where number of moles is 0.5 and molar mass of copper sulfate crystals, which is hydrated copper sulfate, is 250. So it should be 125 grams. So in 0.5 moles of that substance has a mass of 125 grams. As simple as that. Yes, you can rearrange your formula and use it accordingly depending on the question asked. So basic formula is number of moles is equal to mass by molar mass. So in the given mass of the substance, how many number of moles are present? So you should be using this formula. 0.25 moles of water has a mass of 4.5 grams. What is its molar mass? Yes, number of moles they gave you 0.25 moles. Mass also they gave you 4.5 grams and they're asking for the molar mass. As simple. So number of moles is equal to mass by molar mass. Molar mass is equal to mass by number of moles. Mass is 4.5 grams divided by 0.25, which is number of moles, which is nothing but 18 grams. Yes. So molar mass of water is 18 grams, which you already know. So this is the concept of moles. So mole is nothing but the counting unit. It's the amount of the substance. And 1 mole of any substance has Avogadro number of particles. That particles can be atoms, molecules, or ions. And it is a mass. 1 mole of any substance has a mass equal to its relative molecular mass expressed in grams. And one more formula which you have learned here, yes, is number of moles is equal to mass by molar mass. And also we have found out the percentage by mass of composition of a particular element in this particular video, where it's just the percentage composition of that particular element is mass of that particular element by molar mass of that compound into 100.